Hello and thank you for watching this video. The topic of this video is occupational safety with a special emphasis on occupational safety research that is conducted by the Auburn Occupational Safety and Ergonomics team. For this lesson, we're going to cover a very brief introduction of occupational safety. We will then discuss some examples of Auburn safety research. And finally, we will hear from PhD student Rong Huang Fu about the Xsens motion capture system that is used for safety research conducted at Auburn. The lesson will conclude with a video showing a basic lifting task and the corresponding Xsens output. The driving force for occupational safety professionals and researchers are the 4,600 fatalities and 4 million estimated injuries and illnesses that annually occur in the United States. Occupational safety professionals have many responsibilities within organizations, but are primarily tasked with ensuring that businesses in compliance with all applicable regulations, as well as taking proactive measures to reduce injuries and illnesses among the organization's workers. There are two primary federal agencies concerned with occupational safety and health. The Occupational Safety and Health Administration, or OSHA, is tasked with enforcing safety and health regulations to prevent injuries, illnesses, and fatalities, as well as issuing penalties for businesses that injure employees. The National Institute for Occupational Safety and Health, or NIOSH, is tasked with conducting research and making recommendations for the prevention of injuries and illnesses. Auburn University, in conjunction with the University of Alabama at Birmingham, comprises the NIOSH Deep South Education Research Center. The Deep South Center directs funding for occupational safety and ergonomics research projects that focus on the prevention of occupational injuries and illnesses. Safety research is an important component of the research conducted within the Auburn Occupational Safety and Ergonomics Research Group. A few of the studies that are currently being investigated involve emergency egress and machine guarding. Emergency egress simply means how occupants of a space exit that space during an emergency situation. One study being conducted is investigating different crawling postures that occupants or firefighters use while exiting buildings. Different postures have an effect on energy expenditure and the amount of time it takes to exit the building. By measuring energy expenditure, fatigue, and time to evacuate, recommendations can be made for ideal crawling postures and the number of exits a building should contain. Another study being conducted involves emergency egress down a staircase. Similar to the crawling study, the researchers are interested in methods of egress down a staircase, especially when vision is impaired by an assisted breathing apparatus. A final study on emergency egress is not necessarily occupational in nature, but uses the same principles and equipment to assess efficiency. School bus accidents resulting in an incapacitated bus driver and a bus full of kindergarten to second graders was studied. The forces required to open the emergency exits and the ability of children to safely and quickly evacuate the school bus in a rolled over configuration were studied. A final study that will be discussed in further detail regards employee hand speed. Machine guards are placed around dangerous moving parts of machinery that could catch and injure body parts. The current OSHA standard for the speed at which a person can move their hand toward and away from the dangerous parts of the machinery is based on a study with questionable methodology, such as a small sample size of only male subjects and ideal working conditions for movement. A new study will use a larger and more representative sample size, as well as the newest technologies to measure body movements. Next, we will explore the Xsens motion capture system. All right, today we're here to talk to you about Xsens and, in general, occupational safety and ergonomics research that we do as a group using our Xsens system. So, Ron, what is Xsens?
Okay, Xsens is a motion capture system, like here, sensors.
So, how do we use Xsens? If it's just a motion capture system, what is a motion capture system?
Okay, motion capture system for this particular one is to try to capture motion. It's very easy to understand. So what they do and what they use is they're using 17 this sensor, which is IMU based, inertial measurement unit. So they're using acceleration, orientation of the data from the sensor which attests to each of your segment. This is a forearm, like upper arm, your leg, your feet. So they can use the information to generate this orientation of your segment, so it can capture your motion based on this information.
Okay, so how do we use that data? Why would we ever want to collect that data?
So when we think about occupational safety in the case we're talking about, so it's all about motion, right? It's about your movement to accomplish a certain task. And the risk associated with those tasks is coming from your motion, and definitely get involved with the force you're applying or exerting. So this Xsens motion capture system will make us be able to quantify your movement, and based on this information and combined with force data, we can do some calculation and assess the risk associated with some particular tasks, movements.
Okay, so that's all relatively abstract. Why don't you give us a real-world example about how we can use the data from Xsens in order to assess a job and see how we could better perform that job in order to reduce physical risk.
Okay, so as Bob said, we're going to try to do a very simple task. So for example, lifting a box, right? Lifting a box, there's two ways of doing that. We're going to later show it in the model in the computer. I'll just give a little demo here. So from side views, I can directly bend my trunk, lifting a box, right? That's easy one. Or in other words, I can bend my knees a little bit and grab the box tip. So just a little bit different strategies of lifting this particular box. So from Xsens, we'll be able to quantify, okay, the force, which is the box, how far they are from your low back to this particular box. Because of using this distance information and the force of the box, we will be able to calculate a moment that exerting to your low back, which indicate how much the risk is for low back pain, potentially.
Okay, that's a great example. So what specific research are we doing at Auburn using the Xsens system? Which studies have we done in the past?
Okay, we have been using Xsens in a lot of different scenarios, not only in occupational safety, but also in some other areas. For example, we have using the Xsens system to evaluate the Ingress for the cars, which is funded by Hyundai and Kia. So they are interested in how people get in and get out of the car, right? You think about different age group, different BMI people, different gender, they may get out of the car a little bit differently from each other. So with this motion capture system, we'll be able to quantify the motion, the movement, so kind of to identify their particular strategy and their path of the movement they get in and get out of the car, to provide some information for their design team to better accomplish the design task for the customers, to make people either easier to get in, get out, or give them more space feel when they get out of the car. So sell more cars, final idea. So some other studies that we have been doing is, so we have been performing evacuation studies. So what is that is about is, okay, so in an emergency situation, especially fire emergency, so we would like to know how fast people can actually get out of a place. If you think about like a high-rise building, right? Stairs, that's a place you would like to get out. Probably there's the only access you can have during that scenario. So how people actually performing that particular evacuation tasks? We don't really know how that thing works. So with this motion capture system, which is wireless, so we don't necessarily need to follow the subjects or kind of impact the way they're performing. So we kind of hide in the shade to collect those data, which get us a better understanding of how people perform evacuation tasks. And we have another study which is going to happen very soon. Is one of our PhD student, Richard. He's trying to perform a hand speed testing task. So what is that about? So when people design machine guarding or something like that, so they need to have assumption for your hand speed, right? From the stop point to reach to the movement point of the machine. So that distance is very critical based on your hand speed. However, this study, according to Richard's literature review, is their database is far too old. It's like early 20th centuries. You know, at that time the technology is just basically no technology for hand speed testing. So now, since we have those new technologies, we can have a better estimation of how people actually can perform, how fast they can go with their hand. So with this technology, which Richard is going to test about 60 subjects, so to measure actually how fast people can go with their hand in a standing posture, which will potentially impact the standards for machine guarding design and the assumption of hand speed.
All right, thank you. Next, we're just going to show you some tasks that we're going to perform and what we can actually see within the Xsens system as far as the virtual version of what Wrong is doing in the real world.